All right, we're going to go over the study guide for the Iowa Western Stats final exam. Um, this is required for the class. So I will go through each question. The final exam is 25 multiple choice questions. And I've laid out this study guide so that number one on the study guide will be like number one on the final, number two will mimic number two, so on and so forth. So let's get started. Determine whether the following random variables are discrete or continuous. This goes back to the this stuff that I shared with you that has the kind of the extra stuff that we never covered in the class. So the way we remember it is that continuous data is measured, discrete data is counted. So if it's measured, it's continuous. If it's counted, it's discrete. So the number of pets in a household, that would be an example of discrete data because it is counted. So this first one right here is discrete. The temperature in a room is measured. Okay, therefore that is going to be continuous. So the second one is continuous. The amount of liquid in a pop bottle, that is something that is measured. Okay, you measure the amount of liquid, the number of ounces or the number of liters. That would also be, continuous. And the last one, the amount of change in a person's pocket, that is something that's counted. You count the number of cents. Therefore, we say that that is discrete. Okay, so to sum up, these two, this one and this one are discrete, and this one and this one are are continuous. Okay, I should mention if you miss any of these answers as I'm going through this, I will also share with you the answer key at the end, so you don't miss any of those answers. So let's go to number two. Number two also has to do with this, with your levels of measurement. So determine which of the four levels of measurement, nominal, ordinal, interval, and ratio, is most appropriate. The gender of a student in class. Okay, the gender of a student in class. So that would be one of these four here. The gender would be a category, so that tells me it's got to be nominal or ordinal. Um, the difference between nominal and ordinal, remember, is that in ordinal there's an order, there's a specific order, there's a ranking involved. In nominal, there is no ranking involved. So in this particular case, the gender, okay, that would be an example of nominal data. The satisfaction rating of a customer. Keyword is rating. That implies that there's a ranking involved. There's a specific order involved. So that would be ordinal data. So this first one right here is nominal. And this second one of number two is ordinal. Okay. Number three, identify which of these types of sampling is used: random, stratified, systematic, cluster, or convenience. From a boarding list, randomly choose 5 people flying first class and 25 of the other passengers. So the key in this is that you're choosing a few people from one group, the first class passengers, and you're choosing people from another group. So you're picking and choosing from different groups. So it's either going to be a stratified or a cluster. In this case, it's going to be a stratified. Okay, in a stratified, you're picking and choosing a few from each group. In a cluster sample, you're choosing a whole entire group at random, like choosing all of first class or all of business class or all of coach. In this case, we're picking a few from first class and a few from coach. So again, number three would be a stratified sample. Okay. Number 4, the frequency distribution of the Titanic passengers is given below. It's actually off to the side here. Determine the relative frequency for the first class. Round to the nearest 1/10% if necessary. So round to the nearest 1/10%. So I'm going to pull up my calculator here. And the first thing I'm going to do is I'm going to find the total, since there's no total given. So we have 325 plus 285 plus 706 plus 885. So that's the total. All right, and we wanted the relative frequency for first class. So what that means is what percent of all passengers were first class? So that's 325 out of 2201. Okay, and as a percent, that would be 14.8%. Remember, we moved this decimal over. So it becomes 14.766, so on and so forth. Rounded to the nearest 10th means rounded to 1 decimal place after you convert it to a percent. So the relative frequency would be like I said, 14.8% for number 4. 14.8% is the answer. Okay, number 5. The histogram below or to the right shows the sizes in acres of vineyards in the Finger Lakes region of New York. How many vineyards are included in the histogram? Let's zoom in a little bit on here. Okay, so we're just going to count the number in each category. All right, now this one, the histogram may not be clear because it's kind of between, like here it's between 0 and 5. Here it's between 10 and 15. It will be more clear on the test tomorrow. So it looks like we have 15 for that first bar. And then here, I'm going to call that 13 for that second bar. Like I said, the one on the test will be a little more clear. This third one, I'm going to call that 4, the third bar. And then, so we've done the first 3 bars, and then there's 4 bars left out here that are all at the same level. I'm going to call that 1. So this one's 1, this one's 1, this one's 1. So that's adding an additional 4. So we will say that the answer, how many vineyards are included in the histogram, we will say that the answer is 36 vineyards. We just added the amount for each individual bar. Okay. Number 6. Okay. Find the mean for the given sample data. Unless indicated otherwise, round your answer to 1 more decimal place than is present in the original data values. So in this case, all of these data values are to the nearest whole number, which means when we do our answer, we'll round it to the nearest 10th, 1 decimal place. So the number of cups of coffee that a statistics teacher needed to survive the day is given below. Find the mean cups of coffee. Now, one of the other documents I shared with you is this reference sheet, / online resources for your final exam. So one of the things, we are on number 6. This is one of the ones we can do on Statcrunch. So the first thing I'm going to do is I'm going to take the numbers here. Let me see if I can copy and paste these. On the exam, you'll actually have to on the exam, you'll actually have to put those answers in. So I'm putting them in a column. Right, this makes it a little easier. So we'll get rid of those. So I put all of the data in a column, 2, 6, 6, 9, 11, and 14. So it says here, to find the mean, we're going to do stat, summary stats, and column. All right, so we're going to go stat, summary stats, column. And I'm going to choose column 1 because I put all the data in column 1. And let's see here. We're finding the mean. The mean in this case is 8. So the answer to number 6, find the mean cups of coffee, the answer is 8. Okay. Number 7, we're going to do the same thing, except now it looks like instead of finding the mean, we're going to find the standard deviation. So once again, I'm going to take this data and I'm going to put it into Statcrunch. Okay, so let's erase this first. All right, 16, 18, 28. So I have all of the data for number 7. I have that data in a column, and like my reference sheet says, I'm going to do the same exact thing. So I'm going to go to Stat, Summary Stats, and I'm going to go to Column. I'm going to choose Column 1. I'm going to compute. And once again, the only difference is now I'm going to look at standard deviation. Okay, we're going to round it to 1 decimal place. So rounded to 1 decimal place would be 6.0. 6.0 would be the standard deviation here. Okay. Number 8. The modified box plots below, or to the right, represents a sample of speeds from steel and wooden roller coasters. One outlier has been denoted with a circle. According to the box plot, what are the third quartiles for both steel and wooden roller coasters? So these are box plots. So if we forgot, okay, on a box plot, whether it's horizontally or vertical. If it's a horizontal box plot, we'd look left to right. If it's a vertical box plot, we'd look bottom to top. For example, the bottom or the leftmost whisker, that's your minimum. And then the left or bottom part of the box, that would be your first quartile, Q1. And then the line in the middle of the box is the median. And then the line at the top of the box, okay, would be your third quartile. So because it's vertical, the third quartile is at the top of the box. If this were a horizontal box plot, it would be the right part of the box. So the third quartile here for steel would be approximately 80 miles per hour. And then for wooden, let's call that, I don't know, we'll call that, say, 65 miles per hour. So the answer to number 8 for steel would be 80 miles per hour. And for wooden, we'll say 65 miles per hour. Number 9. Number 9. Looks hard, but it's not really. Okay, find the indicated complement. Hint, the complement is the probability of an event not happening. So if the probability of A is 5/23, okay, find the probability of a complement. So the probability of some event happening is 5/23. The chance, so if that is the chance of some event happening, the chance of it not happening, otherwise known as the complement, would be 18/23. How did I get that? Well, I did 23 minus 5. Notice if I add these fractions, 5/23 and 18/23, I get 23/23. That's everything. So the chance, the probability of a complement, in other words, the probability of A not happening, is going to be 18/23. That is the answer for number 9, 18/23. Okay. Number 10, you are dealt 2 cards successfully without replacement. So that's the key. You're dealt 2 cards successfully from a shuffled deck of 52 playing cards. Find the probability that both cards are hearts. So the first thing, we know that there are 52 cards in a standard deck. Out of those 52, how many of them are hearts? Hopefully you know this already, but there are 13 of each suit in the deck. So the probability, and I'm going to put this in here for those of you that are visual learners. So the probability that the first card is a heart is 13 out of 52. Okay. The key is without replacement, the second card being a heart would be 12 out of 51 because it's without replacements. Okay. It says it specifically in the problem. Okay. Without replacements. So to find the probability, we're just going to multiply these 2 fractions. Okay. Now it says to express your answer as a simplified fraction. So to write the answer as a fraction, we're going to multiply the numerators and we're going to multiply the denominators. So the 2 numerators are 13 times 12, and the 2 denominators are 52 times 51. So my total probability is 156 out of 2,652. That is not a simplified fraction, okay? That is not a simplified fraction. So if you want to be able to simplify the fraction, an easy way to do it is to just keep dividing the numerator and denominator by 2 until you can't anymore. So 156 divided by 2 is 78. 2652 divided by 2 is 1326. So if I divide everything by 2, okay, I get 78 out of 1,326. Okay? That is still not fully simplified because both of these numbers are even. So let's do 78 divided by 2 and 1326 divided by 2. Now I'm at 39 out of 663. 39 out of 663. Okay. Now, we know that they're not divisible by 2, right? Because they're both odd numbers. So let's see if they're divisible by any other numbers. Like, is 39, for example, divisible by 3? 39 is 663 divisible by 3? Yes, that one is. Okay, so notice, so as I simplify it even further, okay, I can divide 39 by 3, and I can divide 663 by 3. So I can simplify it even more to 13 out of 221. And if I keep checking, that is it. Okay, so the answer to the answer to that question, okay, express your answer as a simplified fraction, is 13 out of 221. Number 11. What is the probability that a person chosen is a supervisor given that it is male? Okay. So, what is the probability that a person chosen is a supervisor given that it is male? So, in other words, out of all of the male employees, how many of them are supervisors? So let's find a total here. 45 and 8 is 53, plus 7 is 60. So there are 60 total male employees. Out of those 60 male employees, how many of them are supervisors? So 8 out of the 60 males, let's clear this out. 8 out of the 60 males are supervisors. So that is my answer. Round your answer to the nearest thousandth. So 3 decimal places would be 0.133. Okay. Number 12, a commuter must pass through 5 traffic lights on her way home from work and will have to stop at each one that is red. She estimates the probability model for the number of red lights she hits as shown below. So what this means is the probability that she doesn't hit any red lights is 0.05. The probability that she hits one red light is 0.25. The probability that she hits 2 red lights is 0.35, so on and so forth. So find the probability that she hits at least 3 red lights. So at least 3 red lights means 3 or more. 3 or more means these 3 right here. So the probability that she hits 3 red lights, so that's 15%, 15%, that's 30%, 35%. So the probability that she hits at least 3 red lights would be 0.35, 35%. Okay. Number 13. Find the mean of the given probability distribution. Mean is the same as expected value. Okay, so if you forgot, the way we find the mean or the expected value of a probability distribution is to multiply each number times its probability and then add everything together. So in other words, 2 times 0.3, 4 times 0.4, 6 times 0.2, 8 times 0.1. Multiply all those together and then add the answers. So I'm going to quickly do this on Desmos. So it'll be 2 times 0.3, and then 4 times 0.4, and then 6 times 0.2. Whoops. And then the last one, 8 times 0.1. Okay. So to answer the question, find the mean or the expected value of the given probability distribution. The answer is 4.2. Okay. Number 14. About 8% of males are colorblind. A researcher has a list of 12 men who have volunteered to be tested. What is the probability that exactly 2 of the 12 men are colorblind? Round your answer to 3 decimal places. Okay, so I'm going to go back here. Okay, and for number 14, we're going to use the Statcrunch binomial calculator. So on Statcrunch, we're going to go to Stat, we're going to go to Calculators, and we're going to go to Binomial. Okay, so let's go to the question here. Okay, so the n value, that is the sample size, so that is a list of 12 men, so n is going to be 12. P is the probability, so the probability is 8%, so that will be 0.08. And we want the probability that exactly 2 of the 12 men are colorblind. So I'm going to make this equals, because it says exactly, and make this 2. So the probability that exactly 2 of the 12 are colorblind, there's our answer. Okay, round your answer to 3 decimal places, so that will be 0.183. So the answer to number 14 is 0.183. Okay. 15, 16, 17, 18, we're going to use the Statcrunch normal calculator. So on Statcrunch, if I go to Stat, Calculators, and Normal, this is what we're going to use for the next 4 questions, 15 through 18. Okay? So find the indicated z-score. The graph depicts the standard normal distribution with mean 0 and standard deviation 1. So mean is 0, standard deviation is 1. Now notice the way the graph is shaded. Notice the graph is shaded from this point above. Okay, that implies greater than or equal to. So I'm going to make that greater than or equal to. And notice it tells me that the shaded area is 0.0532. So 0.0532. Okay. Actually, I screwed up on this one. I screwed up on it, and I'm glad I did. So then you can see how it's easier, um, to mess up. What this 0.0532 is, that is actually what the probability is. So what this number is asking, what this question is asking is what number will give me a probability of 0.0532. So remember with that, we're actually going to put the 0.0532 after the equal sign for this one, because that we want that to be the answer. We want that to be the probability. So if I set it up this way, this will tell me, okay, what number gives me a probability, what number gives me a probability of 0.0532, that will give me the answer. And you can see now that graph actually looks like this graph. All right. So we're going to round that to, it doesn't say, so we'll just round it to 2 decimal places here. So we're going to say that the answer is 1.61 for number 15. Okay. Number 16, a forester measured trees in a forest and found a mean diameter of 10.4 inches, standard deviation of 4.7 inches. Suppose that a normal model applies, about what percent of trees should be less than an inch in diameter? Okay. So we're going to again go here. Our mean this time is 10.4 inches. Our standard deviation is 4.7 inches. And we want about what percent should be less than. So that implies that this has to be less than 1 inch. So the question is the one gonna go here or is it going to go here? So the key is in the question, it says what percent. Okay, that in other words, it's asking us to find the probability. Okay, so that 1 is actually going to go here. Okay, okay, we're asking for the probability that it's less than 1, the percent that is less than 1. If I compute, I get that. Okay, and about what percent of trees? So as a percent, that would be 2.28%. So we'll say that the answer is 2.28%. 2.28%. So that's the answer to number 16. Number 17, the weights of Angus steers are normally distributed with a mean of 1,152 and a standard deviation of 84. Find P40, the weight that separates the lower 40% from the top 60%. Okay, so let's go ahead and change. So the mean was 1152. Okay, the standard deviation was 84. Okay. Now notice here it says the weight that separates the lower 40% from the top 6. So it's telling us what the percentage is, 40% or 60%. So we're going to put that number after the equal sign. Now it turns out there's actually 2 ways we can do this. Because notice it says the weight that separates the lower 40 from the top 60%. So if I choose to use 40%, I could choose to use 40%, then it's going to be the lower 40. So I'm going to make this less than, I'm going to make this 0.40 or 0.4, and I'm going to get an answer. Okay. The answer is 1,131 pounds. Okay. Now, if I erase this, so remember that number, 1,131 pounds, I could also choose to use 60%, but now I'm going to do top 60. So top 60 implies that this has to be greater than, and I'm going to put 0.60 or 0.6. And notice, if I do that, notice I get literally the exact same answer. So I get 1,131 pounds approximately. So the point is, you can do it either way. You could choose to do lower 40, or you can choose to do top 60. Either way, you get the answer of 1,131 pounds. That is the answer to number 17. Number 18. Excuse me. The body temperatures of all adults are normally distributed with a mean of 98.6 degrees and a standard deviation of 0.7389. So let's change that. 98.6. Standard deviation 0.7389. Okay. What is the probability that the mean body temperature of a randomly selected group of 52 adults will be less than 99.638 degrees? So we want the probability that it's going to be less than 99.638 degrees. And we get an answer of that. Now, does it say what to round it to? No. So let's just round it to 2 decimal places. We'll call that 0.92. It's about 92%. All right. This is pretty straightforward. The one thing I want to call your attention to is, did the fact that there were 52 adults, did that even matter? And the answer is no. Okay, that was useless information that was thrown in there to try to throw you off. So the answer again in this case is 0.92, approximately 92%. All right. Now we're doing number 19. Okay, assume that a sample is used to estimate a population proportion P. Find the margin of error, ME, that corresponds to the given statistics and confidence level. Round the margin of error to 4 decimal places. So among 1,815 randomly selected high school students surveyed by the Centers for Disease Control, 417 said they were current smokers. Find the margin of error for a 95% confidence interval used to estimate the population parameter. So if we go back to our answer here to number 19, we are going to first go to Statcrunch. Okay, we're going to do a confidence interval. So we're going to go to stat, proportion stats, stat, proportion stats, one sample with summary. So stat, proportion stats, one sample with summary. Okay, so 417 out of my sample size of 1,815. Okay, said they were smokers, and we were doing a 95% confidence interval, right? Let's double check that for a 95% confidence interval. All right, so if we do that, we compute, we get this answer. Okay. Now that's not the answer, because the answer says find the margin of error. So notice it says the margin of error is half the difference of the upper and lower limits. So we're going to take the upper limit minus the lower limit, and then we're going to divide that difference by 2. So I'm just going to copy and paste here into Desmos. I'm going to copy and paste into Desmos. Okay. Okay, so so we're going to take the upper limit minus the lower limit divided by 2. And the answer, excuse me, the answer is the margin of error. So it says to round the margin of error to 4 decimal places. So if we do that, our answer is going to be 0.0194. So again, the answer to number 19 is 0.0194. All right. Number 20. All right. So on number 20, we're going to do the same thing we did for number 19, except we're going to go T-stats. So we're going to go stat, T-stats, one sample with summary. Okay. So a researcher found the body temperature of a randomly selected group of 52 adults. So that right there is the sample size, 52. Found that the mean temperature was 98.285 degrees. So 98.285 degrees. And the standard deviation of 0.6824 degrees. So 0.6824 degrees. Construct a 95% confidence interval for the true mean temperature of all adults. So confidence interval, 95%, 0.95. There's our answer. So does it say to round? I'm going to say let's round to 1 decimal place. So the lower limit will be 98.1 degrees. And then the upper limit will be 98.5 degrees. So 98.1 to 98.5 degrees. That would be my answer for number 20. Okay. Number 21, there will be a question number 21 on the test. However, it's a bad question. We are skipping number 21. You will also skip number 21 on the test. On the actual test, I will actually give you the answer. I will actually tell you what the answer is to number 21. Like I said, it's a bad question. I don't want you to do it. So we're going to skip ahead and go to number 22. Okay? Express the null hypothesis and alternative hypothesis in symbolic form. Okay? Use the correct symbol for the indicated parameter. So 20% of cars of a certain model have needed costly transmission work after being driven 50,000 miles. Okay, that's actually a typo there. Okay. All right, so 20% of cars of a certain model have needed costly transmission work after being driven 50,000 miles. The manufacturer wants to know if this percentage is correct or not. Okay, so that we are being asked for, if we were to do a hypothesis test, and let's review here. When we do a hypothesis test, whether it's proportion stats or t-stats, but let's just go proportion stats. If we were to do a hypothesis test, what would our initial guess be? What would our alternative guess be? So in this case, we are guessing that the proportion is 20%. So 0.2. And we're being asked, is this percentage correct or not? So the way that is worded, does that imply less than, greater than, or not equal to? It doesn't apply less than or greater than. So we're going to choose not equal to. So if we were going to do a hypothesis test, this is what we would put in here. So this right here is your answer to number 22. What I just highlighted on my screen here. That is the answer to number 22. Okay. We are up to 23. Okay, 23, we're going to do Statcrunch T-stats again. So we're going to do Statcrunch T-stats, one sample with summary. Okay. Find the value of the test statistic T. Round your answer to 2 decimal places if necessary. Hint, go through the same process of finding the p-value on Statcrunch. One of the other values will be the test statistic T. So a claim is made that the average driving age in a state is 56. In a random sample of 42 drivers, so 42 is the sample size. Okay. In the state, the average age was 52. So the sample mean is 52 with a standard deviation of 6. Okay. Okay. So what number is going to go here is going to be the 56. That's the claim. The claim is made that the average driving age in a state is 56. Okay. Now, is there anything here that would imply whether this was less than or greater than? The answer is no. So we're going to leave that as not equal to, and we're going to compute. Now, when I look here, we normally look at the p-value, but one of the other things that's there is the t statistic, and that's what it's asking for. Find the value of the test statistic T. Well, the test statistic T, does it say to round your answer to 2 decimal places? So that would be negative 4.32. So the answer to number 23 is negative 4.32. Okay. Number 24 we are up to. Number 24, we are going to use this link here. So let's click on this link. Okay, and this is what we're going to use to solve number 24. Okay, so the test statistic in a two-tailed test is z equals 1.65. Okay, use 0.05 significance level, it says. And what did it say? It said a two-tailed test. So we're going to choose two-tailed. Okay, so this is the information we're going to put in, and then we're going to hit calculate. Okay, so the p-value, so to answer part A, use the given information to find the p-value. The p-value is 0.099. 0.099. Okay, so the answer to part A is to 0.099. Okay. B, use a 0.05 significance level and state the conclusions about the null hypothesis. Okay, so remember our when we look at the p-value, if it's less than 0.05, then we reject our initial guess. That means our initial guess is false. Okay, whereas if our p-value, which in this case was greater than 0.05, greater than 5%, then that means that our initial guess was true. Okay, so our two choices here, and you'll see this on the final, okay, in formal language, that would be either reject the null hypothesis, meaning that the initial guess is false, or fail to reject the null hypothesis. Well, fail to reject means not to reject, which means it's true. So the p-value being greater than 5% means that our initial guess, the null hypothesis, is true. So we would say our conclusion is fail to reject the null hypothesis. Again, the answer to part A is 0.099, and the answer to part B is fail to reject the null hypothesis. All right. Okay, a garden center wants to store leftover packets of vegetable seeds for sale the following spring, but the center is concerned that the seeds may not germinate at the same rate of 92% a year later. Assuming a hypothesis test of the claim has been conducted and that the conclusion is to reject the null hypothesis, state the conclusion in non-technical terms. Okay, so remember, when we do this, we always have our initial guess and we have our alternative guess. So our initial guess, if we were to do this on Statcrunch, would be that 92% is our rate. Okay. If we were to do this, okay, let me see if the right, here we go. Let me see if I can find the not equal to symbol. Oh, I thought I saw it. Here it is. Okay. So if we were to do this, our alternative guess would be that it's not equal, because it says the center is concerned that the seeds may not germinate at the same rate. So it doesn't specify less than or greater than, so we're going to go with not equal to. So let's just assume, so it's saying, let's assume we've done the hypothesis test and that the conclusion was to reject the null hypothesis. So to reject the null hypothesis would mean that our initial guess was false. And if the initial guess is false, that automatically means that our alternative guess is true. Okay? Meaning that it is germinating at a rate that's other than 92%. Okay? So state the conclusion in non-technical terms. In non-technical terms, if this right here is true, that means, okay, the center is concerned. So that means the seeds are not germinating at the same rate. They're germinating at a rate other than 92%. So this would be the conclusion in non-technical terms. That is the answer to number 25. Okay? Now, if you missed any of the answers, I will also share with you, and let me show you what this looks like. I have also shared with you a link to the answer key to here to this study guide. So if you missed any of the answers as I was going through this, you'll see I will post this answer key and you can go through this again. It will be in a separate link. Okay, that is it for your study guide for the final. Don't forget to reach out if you have any questions.